Today's students will apply their knowledge of graphing conics to check their solutions to systems of equations. So we're going to use all of the tools in our toolbox. Okay, I am recording. Do you remember? Can you guys solve this one for me, number 1? Try it. Sure, on your whiteboard. Do one. Okay, recording. First of all, I really liked Michelle said, could I set them equal to each other? I'm going to show you how you could have done that. Sorry, I'm trying to duplicate. Okay, so I'm going to start. Normally, we would just use straight elimination. I see 3y and 3y. If I made the top one or the bottom one multiplied everybody by a negative, this would become positive. This would now be negative, and this would now be negative. It's exactly what it is, systems of equations. So now I'm going to get rid of that, and I've got 10x plus 4x equals 14x. And 22 minus 8 is 16, correct? Did I do that right? 14x, 14. I knew there must have been something wrong. So now what do? Divide both sides by 14, and I have x equals 1. How do I find y? Plug x back in. So we're going to plug x back into, it doesn't matter which one, right? Do it in the top one. So it's going to be 10 x's, which are 1, plus 3 y's must be equal to 22. Subtract 10 from both sides, and I get 3y equals 12. So y must be 4. So my solution to this is 1, 4. What does that? Please stop laughing. 1, 4. What does that tell me? That's my intersection of my two lines, right? That's my solution. All right, you guys ready for another one? Because positive 3y and positive 3y makes positive 6y, so I had to make them negative to eliminate the y's. Okay? Good question. All right, let's go back and see exactly what Michelle said. Could I set them equal to each other? That's a good point. If I were to move the 10x to the other side, I would have 3y equals negative 10x plus 22. And if I were to move the negative 4x to the other side, I would have 3y equals positive 4x plus 8. 3y equals something, 3y equals something. These two are equal, right? 3y and 3y? That means these two are equal. Do you guys see that? No? Let's see. Does 20 nickels equal $1? Do 4 quarters equal $1? $1 equals $1, so 20 nickels equals 4 quarters. Right? If this is equal, if this equals something and this equals something, then these have to be equal to each other. You see it? So if this equals that and this equals that, they're in different forms right now, but they must equal each other. They have to. Because we know they both equal 3y's. Okay? So that's another way. So if you wanted to solve it like that, now since you know this equals that and this equals that, now negative 10x plus 22 is equal to 4x plus 8. And you could have solved for x that way as well. Okay. So you guys want to try another one? Let's do... this one. Okay, so some of you are still stuck. So in order to eliminate my y's, it'd be easier to eliminate the y's than the x's, because on the y's, I've got a 12, right? I've got a 12 and I've got a 6. I could multiply by negative 2 and make this negative 12. But in order to do that, I have to multiply everybody. Everything up there has to be multiplied by negative 2. So keep going with that, okay? You had an idea. You could have divided the top by 2. Yay! That would be even easier, right? I like it. I'm going to divide the top by negative 2. So if I divide everybody by negative 2, I just made all my numbers smaller. Brilliant. So 10x divided by negative 2 is negative 5x. And 12, I'm going to make it black. 10 divided by 2 is negative 5x. 12, this is going to be negative 6y plus 6y. They're going to eliminate. And this is going to become, I should have just wrote it out, sorry. Let's do that. I'm trying to make it as least messy as possible. Because this is going to be negative 6y equals 6 divided by negative 2 is going to be positive 3. Negative 6 divided by negative 2 is positive 3. And now I've just changed my system. No, I'm not. No, we're not going to do it multiple ways, guys. You can either multiply by 2 or you can divide by 2. That's it. Okay. So we can get rid of that. Negative 4x and negative 5x is negative 9x equals, this is going to be negative 27, so x equals 3. It doesn't matter how you do it, you're going to get x equals 3. Doesn't matter. Now what? Plug it back in to either equation. It doesn't matter. The equations are equivalent. Okay, one more? Or do we go on to the harder stuff? Let me show you what the harder stuff looks like. That one's easy. We just did one like it. Right? I could either divide by 2 or multiply by 2. Right? It's easier to make numbers smaller than make everybody bigger, right? Okay. I don't think I'm going to do this one because we just did 2 examples with lines. Let's go further. Okay? These are just lines. We're going to deal with conics. Okay? Actually, I'll do this one quickly because then I'm going to graph it. How about that? Sounds good to you. Okay. So I'm going to divide this bottom one right here by negative 2. When I divide everybody by negative 2, I now have a new system. It's 10x, or a system that looks different, equals 10. And this is going to be negative 10x, and this is positive 4y, and this is negative 4. Now I can eliminate pretty easily. This goes away, and I'm left with negative 5y plus 4y is negative y. Correct? So negative y equals 6. So y equals negative 6. Now I want to find out how much x equals. So if y equals negative 6, x minus 5 times negative 6 equals 10. 10x plus 30 equals 10. 10x, I'm going to subtract 30 from both sides, and I have negative 20. So x equals negative 2. So my solution is going to be negative 2, negative 6. Correct? All right. So I have my answer right here, negative 2, negative 6. Now I'm going to graph both of these. In order to graph them, how would I graph them? You're going to have to put them into slope-intercept form, right? Y equals mx plus b. So this one, I'm going to do the top one first. So the top one, the first thing I do is I'm going to subtract 10x. So I get negative 5y. There shouldn't be any talking right now. Plus 10. Then finally, I have to divide everybody by negative 5. When I divide everybody by negative 5, this becomes y equals negative 10 divided by negative 5 is positive 2x, and 10 divided by negative 5 is negative 2. Now I'm going to graph that, go down 2, and up 2 over 1. Alrighty. So that's 1. Pretty good. And now I'll do the second one. So my second one is 20x minus 8y. So as soon as I change that, that's going to be negative 8y equals negative 20x plus 8. Divide everybody by negative 8. Once I do that, I get y equals, how is this going to simplify? What can I divide both of them by? 4. 4 would be a better one, right? So if I divide this by 4, I'm going to get positive 5. If I divide this by 4, I'm going to get 2. And this is going to be negative 1. Correct? So I'm at negative 1. And I'm going to go up 5 over 2. 2, 3, 4, 5 over 2. And down 1, 2, 3, 4, 5 over 2. Bingo, there's my intersection right there. Does that match my algebraic solution? Negative 2, negative 6? Negative 2, negative 6. Okay? It's a lot of work, huh? But it's no new learning, correct? You've learned this in Algebra 1, right? You've learned how to graph lines. Like all of this is just, now we're just tying it together with the conics. All right. All right, I'm going to eliminate a variable. I've got fractions. How do I get rid of fractions? Multiply. What can I multiply everybody by to get rid of both the 9 and the 4? I could multiply everybody by 36. Right? If I multiply this by 36, and this by 36, and this by 36, I now have a new equation. Why? Right? If I multiply this by 36, what happens to this 9 and a 36? They cancel out, and what's left over? A 4. So this becomes 4x squared. This 9, this 4, and this 36 cancel to make what? What's left over? A 9 comes 9y squared equals 36. Now it's not so scary. Right? What should I multiply this top one by so we could eliminate? I have a 4x squared, and I have this right here, x squared plus y squared equals 9. You're going to want to multiply everybody by negative 4. So now negative 4 times x squared is negative 4x squared. That's going to eliminate the x's. Negative 4y squared equals 5. Now it's not such a big deal, right? There's multiple ways to do this. 36. Oh, I'm sorry, negative 36. You guys are all confused. Sorry. I'm adding 9 minus 4 is 5. There we go. This one's going to actually come out pretty nicely. All right. So now I'm going to eliminate. This goes away. And I'm left with 9y squared minus 4y squared is 5y squared equals positive 36 and negative 36 is 0. That's why I was going to say this is going to be an easy one, because y squared would have to be, y would have to be 0. Yes, it will be on school. So y squared equals 0. Normally I would take the square root of both sides, right? And I would get 2 answers, which makes sense to get 2 answers, and I'll tell you why in just a second. So y equals 0. There's one side. Now we know what y equals. Let's find x. Which one do you want to use? The top one would be easier, right? So y equals 0, so x squared plus 0 equals 9. So x squared equals 9. For as hard as you guys think this is, there's way too much talking going on right now. So x equals plus or minus 3. So I have 2 different solutions here. I didn't even put 3. Plus or minus 3. So I have 2 different solutions. I'm going to make them in green. My solutions are when x is 3, y equals 0, and when x is negative 3, y equals 0. How would I have 2 different solutions? Let's see. What's this? What's this conic? What kind of conic is this? It's a circle, right? It's at 0, 0, it centers at 0, 0, and it goes out 3 in every direction. Let's see if I can draw a nice shape with that. Circle. I still don't understand why the laughing is going on. And what shape is this? It's a hyperbola, right? Because it has a negative sign right here. It's a hyperbola. Where is its center? 0, 0. Yep, and we're going to go out 3. 1, 2, 3. There's my intersection at 3, 0, and out 3 this way. Negative 3, 0. This one, I'm going to go up 2. And down 2. There's my slope box, right? I'm going to do it just really light, because that's not what's intersecting the graph, right? That just shows me where my asymptotes are going to go. And then are my branches going to be on the x or on the y? On the x. So graphically and algebraically, I've solved 3, 0, and negative 3, 0. How many possible solutions could we have had with these two shapes? How many times could they have crossed? 4, right? If this hyperbola was a little bit skinnier, it would have crossed the circle here and here, and here and here. Okay, I think it's time to give you your homework, right? So you can start getting started on it. All right, let's do this. You can just keep them. Thank you. I'll pause recording. 3, 2, 1. All right, here's number 3. Hey, look at these both right here are x squared equals. So couldn't I say they equal each other? I could. So if x squared equals this, and x squared equals this, then they must equal each other. Or I could have just multiplied the bottom by a negative. Would you guys rather me do that? We're actually going to do substitution tomorrow. So I'm going to go ahead and just multiply them by, so this is going to be 8y minus 8 equals x squared. And this is going to be negative 8y times negative 8 times is positive 40 equals x squared. Look, I don't even need to. They're already ready to be eliminated. I don't need to do anything. So this goes away, and I'm left with 40 minus 8, 32. Equals 2x squared, correct? And x squared and x squared is 2x squared. When I divide both sides by 2, I get x squared equals 16. So what does x equal? Positive and negative 4, right? I'll keep going, guys. So positive and negative 4. So now I'm going to have 4 solutions, I believe. So when x equals positive 4, I would have 8y minus 8 equals 4 squared. 8y minus 8 equals 16. Add 8 to both sides, and I get 24 equals 8y. Divide 8 by both sides, and I get y equals 3. That's for 1. Now, if I put negative 4 in here, I'm still going to get a 16, so I know I don't have any more solutions. Does that make sense? If I put negative 4 in here? 8y minus 8 equals negative 4 squared. It's still going to be 16, so I'm still going to get the y equals 3. So my solutions are positive 4, 3, and negative 4, 3. So that's the second one done.